Morning everybody, my name's Simon Murray from Your Maintenance Coach, and I want to talk to you today PMO like a pro. Now, is it PMO, is it RCM, is it a bit of brainstorming? It's a little bit of all of that together. So the PMO purists in the room probably going to hate some of this. But what I want to share with you is a bit of a tool that I've used with clients to really get them started. So this isn't about taking an RCM process to excellence. It's just about how do we improve what we want to do with our PMOs. So most people, most of the time when I start working with clients, it's because they phone, they say, Simon, we need to improve our PM system. Now, usually that's not the problem. The problem's usually leadership, planning and scheduling, a whole host of other things. But at some point, we've got to get to fix the PMs. So, get the clicker working. There we go. So, but why do we want to change our PMs? Why are we actually looking to update them? So obviously, one of the key thing is we want to increase the reliability of our equipment, we want to improve the uptime, we want to reduce the breakdowns. But when I look at this process, there's a couple of other key things that I'm really focusing on. It's not for me, it's not just about the tasks. It's not just about the things the technicians are actually doing. There's a few others. So the first one is, as part of this process, I want to make sure I'm utilizing the best skills for the job. So here we've got a sound recordist. He's not playing the drums. The drummer's not doing the sound recording. We're using everyone for the right skills. I went through this with a client earlier this year. They said, we have 400 PMs. They're all great. But I also need more tradesmen to do all of these PMs. And when we dug into them, of these 400, 200 of them didn't actually need any technical skill whatsoever. You know, these were things, in Australia we call them a trades assistant, someone with good technical knowledge, but they haven't got formal qualifications. The other 20% could have been done by operators. So we were actually, all of this work was getting funneled into our trades and our technicians that didn't need to be. So as part of this process, I'm looking, how do I free up the time of my technicians? The second thing I'm trying to do is make sure I've got a balance in my PMs of detect and prevent. Now, often when I go through a PM system, if you haven't been through a PMO exercise or anything similar before, what you're going to find is most of your tasks are about detecting failures. Go and inspect the chain, report if it's worn. Go and check the sprocket, report if it's worn. What I ask you to do is every time you see something like that in a PM, what are you doing to actually prevent that problem from happening in the first place? Because most of our PM systems, they just grow organically year on year. So I'll guarantee you 80% of the tasks you'll have, go and inspect if this thing is worn. We forget to actually go and prevent that thing from wearing out in the first place, don't we? And the third thing I'm really looking for in this is, let's refine the frequency. Again, I'm looking at how do I free up my technicians' time. We're all short on technicians. How do we make the most of them? As part of this process, you're going to find that you're over-maintaining and under-maintaining certain things. So they're the three key ones for me. But as we get into this, I always like to see, where have our PMs come from? Where's this system actually come from? And there's a few places. So who's had this one? We've had the breakdown, the major breakdown, usually from operations. Did we have a PM for that? Who's had that before? Yeah, everyone has. Can we put a PM in the system? Yes, we can. But what type of PM normally goes in the system? Let's go and do a visual inspection so that doesn't happen again. Yeah. We're not actually stopping the failure. All we are doing is putting something in the system so that the maintenance guys find the problem before operations. Yeah. It's kind of like, honestly, it's almost like the teenager cleaning up the house before the parents get home after the party. Yeah. The problem's still there. All the bad stuff still happened, but it's just this insurance policy. We think if we can stop operations finding out about this, we're doing a better job. It's false. Second place our PMs come from is our OEM manuals. This is real. I still don't know how to describe it. I still don't know how to talk about it, and I really don't know what to do with it. This came from a global manufacturer of equipment, and it was in the manual for a $2 million spiral freezer in a bakery. I got no words, but this was in their PM system. And I asked the technician, what do you do? So I asked one of them, he said, I just look, make sure there's no play in the bearings. I asked the next one, how do you know there's no play? We get the big bar on it and see what we can do with it. And so if there's no play this time, there sure will be next time. So what are they doing? And as I say, I don't know where to go with this one. The third place our PMs come from are our experienced technicians, aren't they? These guys, they're great. These are the people you've had in your business for 30 years, 40 years, and every time something's happened, we just keep adding to it. Now, the problem with that is your PMs are based on old problems. Maybe they're based on one failure that happened 30 years ago that's never going to happen again, but you're still inspecting that piece of equipment every single day. Yeah? And of course, these guys probably love chopping their tree this way. Yeah? Give them a chainsaw, what are they going to say? No, you're taking my work off me. So we've got to work out in those PMs how much legacy, how much history is in there for you. So let's start to get into the process now. Let's start to get into the process of reviewing our PMs. I'm going to share with you a spreadsheet tool I use, very, very basic, no software. But what are the big mistakes I see people make? So the first one is we look for too much detail. Yeah? And this isn't too much detail in the tasks we're doing, it's too much detail in the tool we're using. Yeah, so, I'm all for, and you'll hear some of the speakers today, you can see, when you look at we obviously don't get to see who else is speaking, but there's a bit of a split in today's session between, I think, tools where we just want to get you up and running quickly, get something happening nice and easily, and there's a couple of speakers who are going to show you some best practice examples. And you've got to work out which one of those is right for you. Full-blown RCM, FMEA is not for everybody. Most of my clients are in the manufacturing space. Most of them will use an RCM or an FMEA process on a very, very small amount of their equipment. It's just not necessary for the criticality. Okay? So often we go into too much detail without actually getting the desired results. Okay? And there was a post, it got me back up a little bit. There was a post, someone had posted on LinkedIn a couple of weeks ago. And I won't say where he was from, and he said, it's frustrating to me that 90% of these so-called reliability coaches and trainers have never done a Weeble analysis, and they've never done all these other tools that some of them had never even heard of. And I thought to myself, well, that's because 90% of customers, clients don't need it. 90% of assets don't need it. You've got to tailor it for exactly what you need for your organization. Okay? For some assets, it's perfect. That's what's needed. For most, it's not. So don't go into too much detail. Choose the right tool, because this is how you keep your team engaged in the continuous improvement process. Second one is we ask the wrong questions. What's the survey saying? And this is when we're stood, your typical PMO questions. Let's get all the technicians in front of a machine and ask them, what tasks should we add to the PM? Well, I don't know, because I'm looking at it in the wrong context. What tasks don't add any value and we should remove from the PM? These are the typical, this is what Google will tell you to ask on a PM. Again, if you're asking the two guys with the saw, you're going to get a very strange answer. Okay? So we've got to make sure we're asking the right questions. I'm going to share with you the questions I ask. And then the last one is we assemble the wrong team to do this work. This is my biggest frustration by far. So, these guys only know what they know. They're working in the way they think is good. The best example of this, I was with a client, I was doing some planning and scheduling training with them, and I said, let's have a look at your PMs, what's coming out. No, the PMs are fine. We had some consultants came through last year. We spent $100,000 doing a full RCM. It was great. I said, well, let's have a look. In Australia, you have to buy everybody a beer. So we're looking at all these PMs. They've been through this RCM process, and I went through them all. And what stood out, there was not a single task for condition monitoring in there. No ultrasound, no thermography, no vibration. I said, how did this happen? Oh, well, I said, tell me the process. Well, the consultant came in, young guy, a couple of years out of grad school. He had all these great tools and bits of RCM software, and we put all the information in. He said, but the people in the room, they were our experienced technicians. That's where the knowledge is, surely. I said, but have any of them ever used VA before? Have any of them ever used ultrasound before? The answer was no. So the team who built the new PMs didn't actually understand the tools that were now a possibility. So if your team consists of people who've never used ultrasound before, are you going to get ultrasound as a recommendation in your PMO process? It's not going to happen. So make sure you build that right team. So this clicker is doing its own thing. Let me share with you this process that works. Let's say this is designed to be a very, very simple process. It's designed to be something you can grab good cross-functional team together and get a reasonable result. It's not going to fix everything forever. So what I use as a base is the old DIPF curve. Yeah? So Terence, they've got the SDIPF curve. Don't tell Terence, but I prefer this one. I think it's cleaner. The way I look at this, by the way, is not as a reliability analyst tool. I look at this and I say, so I use this as a kind of a benchmark. I walk into a business and I'll say, where are you spending most of your time? I like to look at this as a maintenance maturity model. How are we growing up the curve? And I believe the role of every reliability engineer is to make sure that the business is moving up that curve. Okay? The other thing I ask is, where are most of your PMs? When you look at all the tasks on your PMs, where are they all? So that's the way I use it. Now, I spoke earlier about asking the right questions. And one of the questions I like to ask is, instead of standing in front of the machine saying, what should we do? I like to say, what tactics, what tools can we use? And the thing I like about the DIPF curve is it gives us a list of nearly every maintenance activity we can do. So if I'm stood in front of a machine or a component, and I'll show you how I do this in a second, I will ask, is infrared imaging number 6 yellow an option on this machine? Is vibration analysis an option on this machine? So we're actually forcing that question. Regardless of the experience in the room, you're actually making sure all of these things are covered in your PMO. Okay? Because as I say, if you've never done precision alignment and balancing, you're not going to think to apply it to your PM unless you've got this as a trigger. Okay? Second thing I like to put on the DIPF curve is my asset criticality. So this gives me a bit of a guide. Let's say we've got criticality 1 to 5. 5 is low. Generally, I would say my critical 5, I'm probably going to run them to failure. My 4s, I'm going to be looking at some preventative actions. My 2s and 3s are when I'm in my precision predictive maintenance. And my number 1s, I'm doing full-blown FMEA, RCM, all the other tools under the sun to try and actually mitigate that high risk. Okay? Now, that's not a rule, but I've found that to be a really good guide as to what to apply when. Because you can't just go out there and start applying all of these tools. You've got to know where to start. Okay? And the third piece I want to leave you with on this is any PM or task you have that is on this side of the curve is only there to detect a failure that's already happened. Yeah? It doesn't stop anything from happening. This will increase your machine availability, will not improve your reliability at any time. Whereas all of the work you do over here, these PMs prevent the failure. These PMs increase your reliability. Yeah? What also happens is all of the PMs, all of the activity you do in this green space, these are actually reducing the amount of predictive preventative work you have to do as well. Every reliability engineer's goal should be to put the vibration analysis program out of business. Yeah? Because why? What does my VA pick up? You know, well, I hear people say, my VA program's amazing. It picks stuff up every single week. So what does it pick up? Oh, they found this bearing we hadn't lubricated. It found this other shaft we hadn't aligned. So maybe you should be spending your money in a different place. Okay, how do we pull this together in an Excel spreadsheet? 3 steps as we wrap up. Really simple. We gather the team together. So you've got a cross-functional team in the room. 3 questions. What are we maintaining? What can fail? What can we do anything about it? So the way I look at this is, I say, and I'm keeping this simple because of the people in the room, the different audience in the room, different skill sets. We've got to move through it quickly. So sub-assemblies, maintainable components. These maintainable components for some of you would be assemblies, so gearboxes, etc. What are the faults we generally see? And can we do anything to stop a breakdown? Can we stop anything from catastrophic failure? And again in this, you know, I'm not going into what constitutes a failure. I'm not going into systems engineering. This is about reviewing the PMs we've got and getting something better into the system, okay? So that's nice and easy. The one thing I would ask you to do when you're facilitating this, it's about the challenge you have when you walk to your machine and say, what are we going to do with it? The challenge there is it focuses people's thinking onto one problem they've had or one individual component. This process is a big brainstorm. We come back to some specifics, brainstorm and specifics, okay? So we've got all of this bit set up. The next set of questions I ask, what tactics can we use? What tactics are practical? Because we can use VA and ultrasound on anything. Might not be the best option. And do we need to run to failure? Because some things will have to run to failure. It's not practical to detect the failure. So my spreadsheet then looks a bit like this. I've taken my components. Across the top, I've got all my potential maintenance opportunities from the DIPF curve. And what I'm doing here with the team, I'm brainstorming still. This is sort of the creative side of our brain. The green spots are where that tool or tactic is relevant to that component. Could it be used? I'm not asking if it's too expensive to use, if it's the right one. Just can it be used? Just do that brainstorm. And then we go back through that, and the crosses are the things that we have deemed the most practical application for it. So, you know, down the bottom here, we've got a gearbox. We could use ultrasound on it. You could use ultrasound on any gearbox, but if that gearbox is 6 meters up in the air, you're not going to be able to. So it ceases to become a practical application. Now, practical for you is different to practical for me, and that's different to practical for the person sat next to you. You've got to work out what that is for yourself. Okay? So now we've got our crosses. The crosses are the things we've decided are probably the best tool to use. Next set of questions. What will we do to detect the failure? We've kind of answered that one. What will we do to prevent the failure? How will we mitigate a run to failure? It's all very well and good to say run to failure is our tactic, but what are we going to do when that component fails? Can't just leave the machine stopped. And while we're here, I always ask, is a critical spare needed? Because it's a useful question while we're at this end of the process. So this one's a bit more wordy for the slide. But essentially, our first two columns here, what's the tool and what's our frequency? Again, gut feel from the experience you've got in the room. We're not digging into software and failure analysis and all sorts of statistical control. Your frequencies, you should be monitoring and updating fairly regularly anyway. So you don't need to get it perfect at this point. Monitor what you're finding from this PM, your resultant work orders. So the first two are what we're going to do to detect it. The second two columns, I forced that question. If you're doing thermography to detect a hot bearing, what are you going to do to stop the bearing from getting hot? Obviously, in most cases, it's going to come down to lubrication. It's going to come down to these. On the DIPF curve, this is our green precision maintenance. So every action should really have something around that green precision maintenance in there. And then the last two columns, I ask, okay, if you're going to run this to failure, what's your mitigation strategy? In most cases, that's going to be hold a spur. Here we defined, this was a servo motor with a VSD. So they needed to hold a spur, but they also needed to make sure all of their settings were catalogued. We've got the spur, but what about when we change it over? Does everyone know how to set it back up again? And then the very last column to wrap up is, do we need a critical spur? Do we have a critical spur? And in the case of this example, this was actually a machine that filled milk bottles. We found that in most cases we had a spare on site, but it wasn't in their CMMS. It was sort of ratted away in someone's desk. But they found about 10% of the run to failure components did not have a spare on site. So that was the main outcome of this. But it also gave them, let's say, this is a milk filling machine. Took a day or two, but they were 100% confident in how that machine is now being maintained. Okay? That's what it looks like overall. Nice and simple, no fancy software, just a spreadsheet with some questions in it. The last step of that is I have a look at my failures for the last 12 months and say, have I missed anything? Of all those failures, is there something on here that would correct it? And I look at the actual PMs that are already in the system and make sure they're together. Thank you very much.
So at what point do you pull in the regulatory type items to merge that into the PMO output?
I've got to be honest, with most of the clients I take this through, because I'm mostly in manufacturing, we don't have a huge amount of that on those types of assets. So in this model, it would be very rare that I would actually need to use that. Where would I pull it in? I would probably put regulatory checks in as one of the types of maintenance that is required. That's where it would fit best. The other thing that you couldn't really see on that is, along with the types of maintenance in there, is specific OEM recommendations. So I'd normally put them in there as well. So that's where it would fit, but yeah, generally I wouldn't use it a lot. Yeah.
Thank you for your talk. Really interesting. Can you comment on, I've always been told that some large percentage of PMs, time-based PMs, are either unnecessary or harmful. What's kind of your thoughts on that?
I agree completely. And it comes from this, really the first thing I always want to look at, and this came up in the frequency a bit, is moving as much as you can, as quickly as you can, from time-based weeks to at least run hours or usage. That will overcome some of that. But yeah, most of them are in there because it comes down to who creates them and how they create them. In Australia, lots of places I go to, the maintenance planner's responsible for maintaining the PMs. And it's sort of, we just do it every week or every month, and of course that doesn't align with the failure codes. So where that logic comes from, obviously, is that applies for anything that has a linear failure rate. So chain stretching, wear strips wearing, yes, we can check them every month and monitor them, but most of our failures are just completely random. We don't know when they're going to happen. And I say random, they're random, but they're self-inflicted. Motors don't fail. I think Terence has got a poster, motors don't fail, they're murdered. Gearboxes and bearings should last forever. So why inspect them every month? We inspect them every month because we're not doing enough of that precision maintenance in the green zone. Okay. Thank you very much.